Hi, this is Mr. V and welcome to this video on Sankey diagrams. In the last video we looked at how to make a energy flow diagram for a specific task. But we can go more specific, and especially in fields of science we love using numbers. So this is really informative when we're looking at the forms of energy involved, but it's not really very quantitative. So the quantitative version of these are called Sankey diagrams. So let's make one. Here is a simplified version of our energy flow to power our phones from the energy we can get out of oils and coal. And you'll see that this time we've got some actual values that we can use. Let's turn this into a Sankey diagram. Now these are quantitative. They have actual values that we're interested in. In this case, we're going to go up to 100. So I'm going to take out my ruler because we want this to actually be accurate. So I'm going to draw, and we're just going to make this 10 centimeters tall, say. And I'm just going to put in some grid marks so we know where every 10 kilojoules of energy is. There you go, each of those is 10 kilojoules, and we're just going to go off. The x-axis here doesn't actually matter too much. It's the y-axis, the energy axis, that we really care about. So right at the beginning, we have 100 kilojoules of energy. So all of this energy here is in our oil. All of that energy is in the oil. But between the oil and the thermal energy stage, we're dropping down to 80. So when we reach the next step, we drop down to 80 kilojoules of energy. So only this much energy is actually in our fire. The rest of this energy is lost. And we represent that by having this energy flow out. So we have 80 kilojoules of energy, and in this step we're losing a lot of energy. We're losing 50 kilojoules of energy. Like, a lot of energy here is being lost. So from the fire to our turbines, we are now down to 30. So 10, 20, 30 kilojoules of energy is in our turbine. It's a pretty small amount. All of this energy is now lost. And look at that. Look at all that energy that's lost. And this is why Sankey diagrams are so useful, because you can see visually how much energy is lost. Only 10 kilojoules makes it to the power supplied to our house. So again, we're dropping down to 10 kilojoules, and this is the energy in the electrical grid. That's called electrical. Only that much energy is now left. The rest, again, is lost. All of this energy is lost. And lastly, our phones. We plug in our phone, some of the energy is going to go into our phone, and still some is going to be lost. Just by our phone operating, it's going to lose some to heat. So only 5 kilojoules of energy makes it to the end stage, the stage that we care about, which is our phone. And again, the rest is lost. So look at this. All of this energy here is lost. 95 kilojoules, 95% of our energy is lost. Only this measly 5 kilojoules of energy makes it down to the phone. And that's what we use to play our games and check out Facebook. This measly 5 kilojoules of energy out of the 100 kilojoules that we started with. The diagram that we've just drawn is called a Sankey diagram, and it shows the amount of energy we have at each step and where that energy is going to go. And that is how you draw a Sankey diagram.